Assalamualaikum. My name is Hamad Isal Jabri. My matric number is AE2000078. This is group project number 4 in electric circuit 1, BEJ10303, section 6, semester 1, session 2020-2021. This project done by Hamad and my colleagues Nick Muhammad Izzat bin Ja'far and Muhammad Fahmi bin Ahmed. Firstly, I will talk about the comparison between mesh analysis and nodal analysis. Then I will talk about the similarities between them. First, mesh analysis. Mesh analysis is the application of Kirchhoff's voltage law (KVL) to solve the mesh currents. It is used to find out the loop currents in the meshes, which is written in terms of voltages R times I. The values of the currents inside a certain part of a circuit are used in mesh analysis. Second, nodal analysis. Nodal analysis is the application of Kirchhoff's current law (KCL) to solve the voltages at each node in an equation. Nodal analysis is used to find out node voltages in the circuit, which is written in terms of currents V divided by R. Nodal analysis is possible when all the circuit elements branch constitutive relation have an admittance representation. The similarities between mesh analysis and nodal analysis. Both methods are used to find current or voltage in a particular branch of an electric circuit, but by using nodal analysis, we can easily find node voltages by using node voltage current, and by using mesh analysis, we can find current in a specific branch. In both the methods, minimum number of equations need to be written to know the unknown quantities. Nodal analysis is best suited when there are current sources, whereas mesh analysis is best suited when energy sources are voltage sources rather than current sources. Calculation task 1. Question. Students are required to do a calculation using nodal analysis and mesh analysis for the circuit given in figure 1. For nodal analysis, students are required to find all node voltages for the circuit, and for the mesh analysis, students are required to find all mesh currents for the circuit. Task 1 answer. Here we have a figure 1 circuit. It is including 6 resistors and 1 voltage source and 2 currents. As you can see here, we have I1 equal 2 ampere and I3 equal negative 4 ampere. It is negative because the current path is reversing the I3. Then calculate mesh I2. After these steps we will get negative 8 ampere. Then calculate mesh I4. After these all steps we will get 4 ampere. Then lastly we calculated I2 and I4 by using system equation technique. So we will get I2 equal negative 40 over 47 ampere and I4 equal 4 over 47 ampere. Second, analyze circuit by using nodal analysis. Node 1. After all these steps, we will get equation 1, 13V1 minus 7V2 equal 8. Node 2. Equation 2 will be 11V2 minus 7V1 equals 64. Then lastly, the matrix of V1 and V2 is 13 minus 7V1 equal 8 minus 7, 11 V2 equal 64. That will be V1 equal 5.70 volt and V2 equal 9.44 volt.
Assalamualaikum warahmatullahi wabarakatuh, and hi, my name is Muhammad Fahmi bin Ahmadi with matric number CE2000010. I am from group 4. Today I'm going to present to you about for the task 2 of our group project. Okay, before I start, let's see the question that have been given to us for the task 2. For the task 2, students are required to conduct an experiment by using any computer simulation tools available, for example OCAD, PSPy, Multisim Electronic workbench or process design suite to prove the result in task 1. Okay, since I don't have either one of those examples of software that have been mentioned, so I decided to choose the Simulink, which is part of the MATLAB software that enable me to do the simulation, subsequently prove the answer for the task 1. First of all, let me begin with the little bit introduction about Simulink software that I use. Okay, Simulink is a block diagram. It's a block diagram environment for model-based design. It supports simulation, automatic code, and continuous testing of embedded. For the assignment, we use Simulink to prove the question in electric circuit for determining the value of the voltage and the current. Okay, let's start our simulation in the MATLAB. Okay, before you want to start to draw or create the electric circuit in the Simulink, you must first open the MATLAB software first, and this layout will be appeared in your laptop. And at the Simulink diagram here, you click on that, and this is this display that will show you. And under the Simscape, you click on the electrical, and automatically the files or the new file will be appeared. But we don't want this file, so we create another new file. And so the other file that appeared in the for the first time, after we click on the electrical, we can close it and we can focus on this file. So before you want to start to create the electric circuit diagram, you must have three important components, which is voltage source, an electrical component or electrical element like resistance, and the voltage measurement to measure your voltage or the current. Okay, to find that, you click on the Simulink library browser. So this Simulink library browser will be appeared in your screen, and you just leave it here so that you can just drag the component that you want to use in your circuit. Okay, after you find your electrical equipment in your Simulink library, you can arrange it like this, so that after you arrange it all of this, you can start your electrical circuit drawing. Like I have it here, I already done my electrical circuit drawing like this. So in it, at here you have node 1, node 2 as the voltage for the voltage measurement, and at here you have another circuit to display your voltage measurement. You have display here, voltage measurement here, and then node 2 and the node 1 and the ground. The ground is representative of this ground. And after you have all this, you can start click on the run, and the Simulink will be run, and the measurement will be displayed on the display. As you can see here, I zoom here. For the node 2, the voltage is 9.447, and the node 1, the voltage is 5.702. Okay, this is for the nodal analysis or nodal voltage. Okay, for the current measurement, the circuit still same. You can refer to the task 1 electrical circuit, but the difference is for the measurement, you change the voltage measurement to the current measurement. And another thing is still same, and the change is you don't have to put this circuit anymore, because this does not require for the mesh analysis or for the current measurement. Okay, for the current measurement, which is we use mesh analysis, your circuit will be arranged like this. So for this current measurement, and this is the display. So the display will be displayed in this display. and after that you just click on the run, and the display will be shown in this display. Okay, for the mesh 1 is negative 0.085, and the mesh 2 here is 0.9362, and for the mesh in here, of course, 2 ampere, because the current source is 2 ampere. And for this mesh is 4, we have 4 ampere here toward the circuit, but the mesh current is like this, so the mesh current will be negative 4 ampere. Okay, that's all for me. Thank you.
Assalamualaikum and hi. My name is Nick Muhammad Aizat bin Jaafar and my nometric is CE200044. Today I want to continue this assignment and I want to continue with this task 3. And next, this is a question for task 3. And the question is, an electronic instrument incorporates a 13 volt power supply. A digital display is at that requires a 5 volt power supply. Unfortunately, the project is over budget and you are instructed to use existing power supply. Using a voltage divider as shown in figure 2, you are able to obtain 5 volt. So the A, select value of R1 and R2 so that the display will be supplied with 4.8 volt to 5.4 volt under all condition of current. B, calculate the maximum power dissipated by each resistor R1 and R2. And the question C, is the use of the voltage divider a good engineering solution? If not, why? And this is a figure task 3. That the input is 13 volt power supply and the output is a digital display. I want to show you my solution this question A. So the figure gives circuit the display supply is 4.8 volt to 5.4 volt. So let's assume we are supplying display by 5 volt. The voltage divider rule. So I use this formula, the voltage divider rule. The formula is VR2 equal 5 equal R2 divided R1 plus R2 multiply 13, or R1 equal 5 R2. So this is my calculation to find the R1 and R2. So 5 equal R2 divided R1 plus R2 multiply 13. So I put the R2 to the right side to find the R1 and R2, and then I got this. And next step is R1 and R2 equal 5 per 6 multiply 1 per 6 R2. And then the last answer I got R1 is 5 and the R2 is 1. So let's take the R2 is 1 ohm and R1 is 5 ohm. So substituting R1 equal 5 R2. Okay, this is all for question A. And then for B, so for the value R2 equal 1 ohm, R1 equal 5 ohm, and the VR2 equal 5 volt. So the power dissipation in R1 and R2 will given by this. I use the formula power. So formula power is P equal V per arc. And then so I'll calculate this, and then I got PR1 equal to 125 watt. And then for PR2 I use the same formula as the PR1, and then I got the PR2 is 25 watt. And the question of C, uh, as we can observe that the power dissipation in R1 resistance is much more than the power dissipation in R2. So, uh, since the power dissipation in R1 is the voltage of the power, hence it is inefficient method. So, hence the less voltage of voltage divider is not a good engineering solution for given problem. This is for my solution for this question. And then the conclusion for this assignment is in both multi-sim application, the simulation of both nodal and mesh analysis is successfully performed. Second, in the other theories, such as the control system, network system, electrical device, etc., the same approach may also be expanded. And three, the nodal and mesh analysis describes the potential difference between nodes and current loops in an electrical circuit as the best approach. And the last but not least, therefore, with the measurement conclusion, the result from the simulation can be gained and justified. This is all from group of. Thank you.